everyone and welcome to my video. So in this video, I'm going to talk about the networking in AWS Cloud. So this is the part of my um, lecture regarding the networking fundamentals. So be sure to watch my videos on my YouTube channel so you don't want to miss one of my video for the cloud networking in AWS. So let's get started. So for this lesson, after completing this lesson, you should be able to explain networking in the cloud, describe the key components of Amazon VPC, and describe virtual networking with Amazon Virtual Private Cloud or Amazon VPC. Networking in the cloud is similar to regular networking in a data center. So as we know, as part of our networking engineering role, so a data center as a whole most closely resembles the functions of a VPC. So in a VPC, you can launch multiple AWS resources that are needed to create a working scalable network. However, within a VPC, no maintenance is required, and you can create an isolated architecture within minutes. Also, a data center involves multiple components such as internet, servers, firewalls, switches, and many more. Like a data center, a VPC requires the same services to operate. Next, we have here the router. A router in a traditional environment has multiple functions such as filtering packets, routing traffic, and storing them in a route table. In AWS, the service that most closely resembles a router is a route table, where the owner inputs routes within the VPC. Next, the switches. A switch acts as a subnet and a switch data as it comes in. AWS uses subnets in every architecture. So every node, for example, the EC2 instances, it belongs in a subnet. Although the functions of a switch and an AWS subnet do not match, the functions of a subnet from the both work the same architecturally. So subnets are used to logically isolate groups of internet protocols together. So we have here our firewalls. So firewalls block traffic based on a set of rules. So equivalent on the AWS services is the security group. The security groups is a services that blocks the traffic at the node. For example, our Amazon EC2 instances and network ACLs. So the network ACLs, it blocks the traffic at the subnet level. These security groups also block traffic based on a set of rules. Next, we have the servers and our operating system. A data center has a servers and operating systems. In AWS, you can use an EC2 instances to launch an array of servers or operating systems. Everything must be connected to the internet through an internet service provider or our ISP. One that you might be familiar with is called a modem, where an ISP provides internet to your home like a modem. A VPC on AWS and its services receives an internet only through an internet gateway. So later on we will talk about what's the functions of our internet gateway. Next, we have here some definition of our Amazon VPC. So Amazon VPC or our Virtual Private Network is a service that lets you provisions a logically isolated sections of the AWS Cloud, or what they call the Virtual Private Cloud, where you can launch your AWS resources. Amazon VPC gives you the control over your virtual networking resources, including the selection of your own IP address range, the creation of subnets, and the configuration of route tables and network gateways. You can use both IPv4 and IPv6 in your VPC for secure access to your resources and applications. You can also customize the network configurations for your VPC. For example, you can create a public subnet for your web servers that can access the public internet. You can place your backend systems such as databases or application servers in a private subnet with no public internet access. Finally, you can use multiple layers of security, including the security groups and network ACLs, to help control access to your Amazon EC2 instances in each subnet. Now we know some of the definitions of our Amazon VPC. Let's proceed on more topics regarding our VPC features. So we know that VPC enables you to provision a virtual private clouds. So a VPC is a virtual network that is logically isolated. So we already mentioned that earlier. So after you create a VPC, you can divide it into one or more subnets. So as you can see on the architecture or some small diagram, a subnet is a range of IP addresses in a VPC. Subnets belongs to a single availability zones or AZ. You can create subnets in a different availability zones for high availability. Subnets are generally classified as public or private subnet. A public subnets have direct access to the internet, but private subnets do not. Now let's proceed on the difference between the default and non-default VPCs. So first, let's discuss about default VPC. So a default VPC is a dedicated to your AWS account. So when you create your AWS account, so essentially you have your own default VPC. So in each region, there's a default VPC. So in every or each region, you have the default VPC there. So if you look into US East 1 or North Virginia, you have your default VPC there. And if you change your region into Oregon or US West 2, you have there the default VPC as well. VPC or the default VPC already has the following features configured. So first, a default subnet in each AZ in each region. So by creating a VPC, the default VPC already has the configuration of the following. So first, the default subnet. And the second one is the attached internet gateway, meaning a default VPC already has the internet gateway attached. So meaning there's already a connection to the public internet. Next, a route in the main route table that sends all the traffic to the internet gateway. So when you create your default VPC, there's a default main route table. So with the combination of that main route table, it has the attached internet gateway, so that the EC2 instances in the public subnet, it has the connectivity to the public internet via the internet gateway. Also, a default VPC has enabled automatic assign of public DNS host names and DNS resolutions. And lastly, it has the default network ACL. Now let's proceed on the non-default VPC. So a non-default VPC is your custom VPC. So you can create your own VPC with the following custom features. You can create your own subnet, route tables, custom network ACLs, internet gateway, and many more. So you have known all about the difference between default and non-default VPC. Now, let's jump in on the IP addressing in Amazon VPC. IP addresses enables resources in your VPC to communicate with each other. And with the resources over the internet, when you create a VPC, you assign an IPv4 CIDR block or a range of private IPv4 addresses to it. So after you create a VPC, you cannot change the address range. So it is important that you choose it carefully. So you should careful on selecting or choosing a CIDR block. Next, the IPv4 CIDR block might be as large as /16, which is it has the 2 raised to 16 or 65,536 addresses available, or as small as /28, which is 2 raised to 4 or 16 available addresses. You can optionally associate an IPv6 CIDR block with your VPC and a subnets in a assign IPv6 addresses from that block to the resources in your VPC. IPv6 CIDR blocks have a different block size limit. So there's a differences between the IPv4 and then the IPv6. So next, the CIDR blocks of a subnet can be the same as the CIDR block for a VPC. In this case, the VPC and the subnet are the same size, a single subnet in the VPC. Also, the CIDR block of a subnet can be a subset of the CIDR block for the VPC. So these structures, as you may see on my virtual private cloud, so this structure enables the definitions of multiple subnets. So if you create more than one subnet in a VPC, the CIDR blocks of the subnets cannot be overlapped. So be sure to or be careful on entering a subnet or CIDR block of a subnet. So you may not experience a IP addresses overlap. You cannot have a duplicate IP addresses in the same VPC. So that's the reason. That's the reasons of the you cannot create a subnets of you cannot have the duplicate addresses. It will cause a overlapping of your IP addresses. When you create a subnet, it requires its own CIDR block. For each CIDR block that you specify, AWS reserves 5 IP addresses within that block, and these addresses are not available for use. AWS reserves these IP addresses for, first we have the network addresses. Secondly, VPC local router or our internal communications. Next, we have the IP addresses for DNS resolutions or domain name systems. And the third subnet which is used for future use, and the last is the network broadcast address. So as you can see on the table, so this mentions IP addresses cannot be used in your assigning on the endpoint of your machine. So it's reserved for something useful in most case scenario. For example, suppose that you create a subnet with an IPv4 CIDR block of the 10.0.0.0/24, which has the 256 total IP addresses. The subnet has the 256 IP addresses, but only 251 are available because 5 are already reserved by AWS. So you cannot use those 5 IP addresses. So be sure to remember that. Next, we have the different types of public IP addresses. So when you create a VPC, every instance in that VPC gets a private address automatically based on the CIDR on each subnet. You can also request a public IP address to be assigned when you create the instance by modifying the subnet's auto-assign public IP address properties. So another types of public IP address is an elastic IP address. An elastic IP address is a static and public IPv4 address that is designed for dynamic cloud computing. You can associate an elastic IP address with any instance or network interface for any VPC in your AWS account. With an elastic IP address, you can mask the failure of an instance by rapidly remapping the address to another instance in your VPC. Associating the elastic IP address with the network interface has an advantage over associating it directly with the instance. So you can move all of the attributes of the network interface from one instance to another in a single step. Additional costs might apply when you use the elastic IP addresses, so it is important to release them when you no longer need them. Next, let's talk about the Elastic Network Interface or ENI. So an ENI or Elastic Network Interface is a virtual network interface that you can attach or detach from an instance in a VPC. A network interface's attributes follows it when it is reattached to another instance. So when you move a network interface from one instance to another, network traffic is redirected to the new instance. Each instance in your VPC has a default network interface. We have here the primary network interface that is assigned a private IPv4 address from the IPv4 address range of your VPC. Take note, or just a reminder, you cannot detach a primary network interface from instance, so you can create and attach an additional network interface to any instance in your VPC. So the number of network interfaces you can attach varies by the instance type. Next, we have here the route tables and then the routes. So a route table contains a set of rules called our routes that directs network traffic from your subnet. For each route, specifies a destination and a target. So the destination is the destination CDR block where you want the traffic from your subnet to go. And then the target is the target that the destination traffic is sent through. So by default, every route table that you create contains a local route for communications in the VPC. You can customize your route tables by adding routes. You cannot delete the local route entry that is used for internal communications. So for each subnet in your VPC, it must be associated with a route table. So take note of that one. So a main route table here is the route table is automatically assigned to your VPC, as you can see on the diagram here. So it controls the routing for all subnets that are not explicitly associated with any other route table. A subnet can be associated with only one route table at a time, but you can associate multiple subnets with the same route table. In the next video, I will be discussing about the network connectivity options in Amazon VPC. So I will be talking about the AWS Direct Connect, AWS site-to-site VPNs, AWS endpoints, and many more. So be sure to watch out of this video to learn more about the different network connectivity options of the Amazon VPC. So that's it for in this video. So see you there. Thank you.